In virtual reality, we often miss one important thing: haptic resistance. That means we cannot really feel how strong or heavy an object is. One common solution is to use physical proxies. For example, you can place a real object in a real world, so the user touches it while seeing the virtual object. But the problem is, if you want to simulate something like a DJ controller with many knobs and different resistance levels, you would need a lot of physical objects. This is not practical. That is why we looked at the paper called Turn It Up. In this paper, the researchers introduced the pseudohaptic resistance effect. This effect works with a visual trick. They use something called a control display gain, or CD gain. This means the movement of the virtual hand is manipulated compared to the real hand. For example, when the user rotates their real hand, the virtual hand rotates more slowly. So there is a small delay or difference between real and virtual movement. Even though there is no real physical resistance, the user can still feel like the knob is harder to turn. We had 7 participants in our user study. It was a within subjects test, meaning every participant tested all conditions. The participants were between 22 and 30 years old, and they had no VR experience. During the test, participants sat at a desk. They had a pillow under their arm to avoid the so-called gorilla arm symptom, meaning the arm gets tired from holding it up. They wore a VR headset, and inside the headset, they saw the knob and the task instruction. At the beginning, they could test how to rotate the knob. After that, they started with the actual tasks. In the first task, participants rotated one knob and answered this question: my real hand rotated farther than my virtual hand. Yes or no? With this task, we wanted to find out the range where the CD gain manipulation is still unnoticed. So we wanted to know, at what point do users recognize that something feels visually wrong? To measure this, we used the interleave staircase method. This is a psychophysical method that helps to find detection thresholds very accurately. In the second task, participants rotated 2 knobs one after another. One knob had a CD gain of 1.0, which means no delay and no manipulation. The other knob had the value we detected in task 1. For example, it could be a CD gain of 0.6. The order was randomized. Participants had to compare the 2 knobs and answer this question. The physical resistance of the 2 knobs felt the same. Yes or no? Our hypothesis was, if participants answered no in at least 75% of the cases, then they really felt a resistance difference. However, our results showed only about 50% no answers, so we had to reject our hypothesis. But we also found a likely reason for this. The main problem was that the hand tracking shifted during the rotation. The tracking was not stable enough while rotating the hand, and this affected the results. Because of that, for future work, we suggest testing the effect with a different interaction. For example, a lateral hand movement, like pushing a linear lever instead of rotating a knob. This could improve tracking accuracy and lead to clearer results. Thank you for listening.